Thank you, Swapnil. And good evening, everyone who is joining with us online as well as who is sitting here in our classroom. Okay, so before starting the topic, I'll just tell you what are the things we are going to cover in hypothesis testing. So first of all, we'll start with what is hypothesis testing actually and how to develop null and alternative hypothesis, type 1 and type 2 errors in hypothesis testing, and one tail test about a population mean with a large sample case, two tail test about a population mean. So all these all these things we'll be going through an example. So let's move ahead. Okay, so first of all, what is hypothesis testing? Hypothesis testing is used where we do not have the information about whole population and we need to infer the information of that population using a sample. There are cases when we cannot measure all the population. So in those cases, we take out the samples, and sampling is a different topic. Sampling is done by many methods like random and all. But once we get the sample, we try to infer the information about whole population. Okay. What we do is we define null hypothesis as well as alternate hypothesis. For example, we have a sample of 30 people, and we want to hypothesize something, tentative assumption that the average height of those people is more than 6 feet. So this is a sample. We have taken a sample of 40 people out of maybe 1,000 population, and we are trying to figure out whether the height of whole population is more than 6 feet or less than 6 feet using the data of that sample. So we will define a null hypothesis as our first assumption, which we want to reject it. Okay, and the opposite of it will be alternate hypothesis. So I'll be telling you this better with an example. So here is the example of a criminal trial. So what judges do or any court does. Null hypothesis in this case, it is denoted by H naught, and the defendant is innocent. And alternate would be the opposite of that, that is defendant is guilty. And now with the help of data, we try to reject the null hypothesis that the defendant is guilty. So this will be cleared with upcoming examples which are coming in the slides. So how to develop null hypothesis and alternate hypothesis. So there are three types of cases. So for a research hypothesis, the alternate hypothesis should be that hypothesis which is new, which has been our research work. For example, a company has done a research which says that okay, I have developed a new process in which my average of the car has been increased from 20 to 24. So this is something new which is not happening. So what was actually happening previously, the cars were giving a mileage of 20 kilometers per liter. So that would be my null hypothesis, and anything new would be my research alternate hypothesis. So let's take an example. As I told you, consider an automobile which has an efficiency of 24 miles per gallon. Okay, and now there is some research work has been done, and now scientists are saying, okay, we can achieve more than 24 miles per gallon. So our alternate hypothesis is our mileage is greater than 24 miles per gallon. Okay, so here it is denoted like this. My null hypothesis is mu is less than or equals to 24, and my alternate hypothesis would be mu is greater than 24. Okay, there is another type of hypothesis where we validate the claim of any manufacturer. So in this case, manufacturer claims are usually given the benefit of doubt, and they are stated as null hypothesis. For example, if a manufacturer claims, okay, my can weights not less than a particular amount, for example 100 ml, so that would be my null hypothesis, and against that the alternate opposite hypothesis would be greater than that. So let's take an example where we'll be trying to develop null and alternate hypothesis. So it's a major West Coast city which provides one of the most comprehensive emergency medical services in the world. Okay, so it is a hospital system. It operates ambulance, and they are claiming that their response time for the ambulances to reach to their patients is 12 minutes or less. They do not take more than 12 minutes. But now they need to prove it. So the director of medical services want to formulate a hypothesis test that could use a sample of emergency response time. So we cannot take all the population data. So here we have to take a sample where my service goal should be 12 minutes or less. So let us formulate this hypothesis. In this case, let us assume my null hypothesis would be that this hospital is sending ambulances within 12 minutes, and alternate hypothesis would be my ambulance are not going on time, so emergency services are not meeting the goal. So this we have developed the hypothesis. Now we need to validate those hypotheses. Now let's see how to validate. But before going to the validation process, let us understand what are the errors a statistician or data scientist can make while doing a hypothesis testing. So there are two types of error. These are known as type 1 error and type 2 error. So whatever null hypothesis we have made, if we reject that hypothesis, but actually it is true, so we will be making type 1 error. On the other hand, if we are accepting null hypothesis when it is actually false, so that we will call it as a type 2 error. So type 1 error is denoted by alpha, and it is called level of significance. So this will be cleared more in next few slides with when we have a normal curve and everything. So let's see now what are type 1 and type 2 errors with this our metro EMS example of hospital. Okay, let's see our null hypothesis is mu, our time is less than 12 minutes, but actually it is correct. Okay, and our hypothesis we are accepting it, so that means that is true, so there is no error. But in case, as I told you, if we reject null hypothesis but actually it is not correct, so in actual the whole population is taking more than 12 minutes and we are accepting it, so we are making type 1 error. Similarly, if the mean time is greater than 12 minutes and we are saying okay, the mean time is greater than 12 minutes based on our hypothesis, then we are correct, we are not making any mistake. But if we are saying that okay, mean time is greater than 12 and we are accepting it, we are rejecting it, so we are making a type 2 error. So there are only two possibilities of making errors. So we will be discussing in deep in coming slides. Okay, so let us understand what are type 2 errors and type 1 error. So remember the first example of fuel injection system of research hypothesis, where we have made our null hypothesis that the mean average miles per gallon is less than or equal to 20, but our research says it should be greater than 24. So we will be making type 1 error if we accept this researchers claim that the new system improves the miles per gallon rating, while actually the new system is same as the current system. So what will it result in? It will result in huge loss of money for that manufacturer. Similarly, type 2 error, we will be making type 2 error if the researcher concluding that the new system is no better than the current system, when in fact it is actually improves the mile per gallon rating. So what will it result in? It will result in huge opportunity loss for the manufacturer. Okay, now let us understand what is p-values. So the p-value is the probability of obtaining sample result that is at least as unlikely as what is observed. So we will be using p-value to make a decision in hypothesis testing using a sample data. Okay, so we have talked about a level of significance alpha where we want that our how much we are confident in saying whatever hypothesis we are accepting or rejecting. So that is based on p-value. If p-value falls within the region of alpha, then we will reject the null hypothesis, and if it is greater than or it will not fall in the region of alpha, then we will not reject the null hypothesis. So we are going to understand this with the use of figure. So let us understand what are the steps of hypothesis testing. First of all, determine the appropriate hypothesis. So we have made null hypothesis and alternate hypothesis, and then select a best test for deciding whether to reject or accept the null hypothesis. So this we can choose test whether it is Z test, T test, or there are other tests also. Specify a level of significance. So generally the level of significance we take is 95%, but if we want much more accuracy, then some people can take 99%. So we will be discussing all this with figures in coming slides. Okay, and then use this level of significance to develop the rule of rejection. So as I already told you, my alpha would be my critical reason. If my p-value is going more than alpha, then we are going to reject the null hypothesis. If it is less than alpha, then we are going to accept the hypothesis. Okay, so moving ahead with our metro EMS example, so let us recall what are the hypotheses we have made. So our hypothesis, null hypothesis was the emergency service of this hospital is meeting the goal, that is they are sending the ambulances to the patients within the stipulated time of 12 minutes or less. And alternate hypothesis is opposite of that, that is they are not meeting the goal, that their ambulances are taking more than 12 minutes. Okay, so here with this figure we have plotted all the sample in the form of normal distribution. Okay, so 12 is our mean, and we need to find out whether they are meeting the goal or not. So this is the normal goal for sample. Okay, so let us take alpha equal to 0.05. So 0.05 indicates, as I told you, that we want to be sure about 95%. So if we consider this normal region as 1, and all this other dark blue region would be 0.95 and this light blue would be 0.05. What these regions suggest are, if my p-value falls in dark blue in this region, then I am going to accept the null hypothesis. If it is my p-value is in this region, then I am going to reject the null hypothesis. So how do we calculate p-values? First of all, we need to understand that. So this here we will see. Okay, so let's suppose we have taken a sample of 40 ambulances. Okay, and their average time for reaching the customer is 13.25 minutes. Okay, and the sample standard deviation is 3.2 minutes. Now let us apply a Z test into it. So our mean is, so we'll calculate the Z value using the formula for Z. So this is x bar minus mu upon standard deviation upon root n. So 13 point, so it is coming out, Z value is coming out to be 2.47. Okay, so since this value is greater than 1.645, so 645 is the Z value when your alpha is this region. Okay, 1.654 at alpha equal to 0.05, my p value is 1.645, but currently my p value, my Z value is coming 2.47, so it is obviously greater than this. Okay, so it is going to fall somewhere here in this region. Okay, So we are going to reject null hypothesis as it is, we found that the Z value is in the rejection region, as we can see clearly from this figure. Okay. So what is our conclusion? We are 95% confident. So here we are using the word 95% confident. That is because we have taken alpha or significance level as 5%. So I told you alpha is 0.05. So here we are 95% confident that metro EMS is not meeting the goal of 12 minutes. So here we have proven that they are taking more than 12 minutes. They need to improve their services. So that is how we do hypothesis testing, and we reject the samples, and again with the help of p-value, using p-value. So here we have done z equal to 2.47. Now with the z table we need to find out the p-value for z equal to 2.47. Using z table we have found out that p-value is 0.068. So again it is going beyond 0.05, it is less than 0.05. Okay, so it is using p-value also it is falling in this range. So we can say we can safely reject the null hypothesis, and we can say this metro EMS hospital is not meeting the goal of 12 minutes. Okay, so let us take a summary of all the possible null and alternate hypotheses about population proportion. So what are the, we have, I request everyone to please their mouth. How will you get it on it? Okay, thank you. Okay, so
one quick
EMS example
question: how do you calculate C value?
What is C value? Sorry.
Quick question: how do you calculate? Just confused that we jumped from bell curve graph of Z, and then we had a bell curve graph of the mean.
What is C?
How do you calculate C value?
Values. Where is C value in this graph?
The previous one, the previous bell curve graph.
Okay. Okay. Okay.
Yeah. So the critical value.
We are talking about
who determines the critical value?
Okay. So this is the value for alpha equal to 0.05. This is the Z value for alpha equal to 0.05. That is calculated using the Z table. Okay. Hello.
Okay. So do we, yeah, I'm listening. So if we move on to the next slide, please. So we have mu, we have standard deviation, we have the sample size. So I don't see alpha here in the Z formula.
Yeah, so alpha is not in the Z formula. It is not in the Z formula. So what is your good name? Can we talk after this session, because other people are also waiting. I'll tell you exactly what is happening here. Okay.
Sure. Thank you.
Thank you very much. What is your name?
Anuj.
Anuj. Okay.
Anuj.
I will talk to you after the session. After this, after we finish this PPT, I'll talk to you. Okay. Thank you very much. Okay. So we have done one type of hypothesis wherein our P was greater than P0 or one value was greater than that. So we can do opposite of it, or it can be like this also, where null hypothesis say is equivalent to some value and alternate hypothesis is not equal to some value. So basically we have done a one-tailed test, and this one, the last one, includes two-tailed test. Okay, so where to use Z test and where to use T test? First of all, we need to understand what is the sample size. If it is greater than 30, then we have to see if my standard deviation of sample is known. If it is known, then we will be using Z test. If it is not known, then we will be calculating or estimating our standard deviation of population using the sample standard deviation. If we can do that, we will be using z-test again. And if it is less than 30, my sample size is less than 30 and my population is still normal, then we need to see whether S is known. If it is known, then again we are going to use z-test, and if it is not known, then we are going to use t-test. And population is, if we find out that population is not normal, then we need to increase the sample size beyond 30 so that it becomes normal. Okay. Okay, so that was it from hypothesis testing. Now I will hand over to Swapnil. He will take you further.
Yeah. Thank you, Ritanshu, and thank you.